Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to look into graphing quadratics as a little prelude to solving quadratic inequalities. So it's probably going to be a GCSE review for most of you, but it's going to be nice and easy. So let's get into it. Okay, so my boys, first we're going to look at the general shape of the graph of a quadratic function. So let's take a look, shall we? The first case here is when you've got a positive coefficient in front of x squared, and what the graph will look like in general is this curvy thing here, where it starts, it shoots down from infinity, comes right back up, and then blows back up to infinity. And how you can think about why it looks like that is, well, for example, if you move across the positive x-axis and you input bigger and bigger numbers into that function, this x squared bit here will kind of dominate. It will grow really, really big, much quicker than this. So whatever's going on over here really doesn't matter for really big values of x. And it will just kind of blow up to infinity, so it will shoot off to infinity. And the same thing happens on the negative x-axis, because when you square a negative number, you just get a really, really big positive number. So on both ends, you get this blow up to infinity, and you get this nice U shape. So that's the general shape of the graph of a quadratic with a positive coefficient in front of x squared. And for the other case, where you've got a negative number in front of x squared, the reverse happens. As you move across the positive x-axis, this x squared gets really big, but it's being negated here, so you get a really, really big negative number. And likewise for the negative x-axis. So for a negative graph, it's kind of going to look like this one, but flipped on its head, kind of. So it's going to look like something like this. So there we go, the general shapes of some quadratics. They tend to look like U's or N's, depending on whether you've got a positive or negative coefficient in front of x squared. Now, let's continue with being more detailed about this. Okay, so my boys, let's try and graph that quadratic equation up there. Now, the first thing to notice about it is it's got a positive coefficient in front of x squared. So as you get bigger and bigger x values, either way, it's going to race off to positive infinity, so you're going to get a general U shape. Now, the main thing you need to be concerned about when graphing any kind of equation, really, or a quadratic, is you're concerned of where it crosses the axes, where it intersects the axes. And we can figure out that pretty easy. For example, where it will cross the x-axis, well, for example, if, I don't know, 3, for example, if it crosses the x-axis at 3, that means that when you chuck in the number 3 to this function, it outputs exactly 0, because you've got a 0 y-coordinate. So what you can take from this is that the function will cross the x-axis at the roots of the quadratic polynomial. So where the function equals 0, it's going to cross the x-axis, and it will cross the y-axis at the input x equals 0, because this exactly here is where x equals 0. So if you chuck x equals 0 into this function, you'll pop out the y-intercept. And those are the 3 pieces of information you need to graph quadratic accurately, and they're what we're going to use in the next episode with quadratic inequalities. So all we need to do is find the roots of this quadratic, and then we find the y-intercept, and we can graph it pretty nice and easy. So, finding the roots. Okay, so we're going to set this equal to 0 to solve, and you might notice, my boys, that looks pretty darn factorable, and in fact, let's try and factor it. So we need to think of 2 numbers where it adds to 1 and multiplies to negative 12, and if you think for a second, you can get 4 and negative 3, right? You can check that that works. So we can break this into 2 factors, x plus 4 multiplied by x minus 3. This is the exact same function, just rewritten. We can set that equal to 0 and do the usual business. From here we get x equals negative 4 as one of our roots, and here we get x equals 3. So we can say, well, at the input x equals 3, and the input x equals negative 4, that's when our function is going to cross the x-axis, because that's when it spits out a y-coordinate of exactly 0. And now, the y-intercept is really a piece of cake, right? All you need to do is plug in x equals 0 to the function and see what it spits out to get the y-intercept. And that's really easy, right? Because 0 squared plus 0 blah, that just gets killed. Anything with an x gets just killed. And so all you're going to be left with is negative 12. So we can say at the input x equals 0, you're going to get a y-intercept of negative 12, which I'll just say is there. I know it's not really, but who cares? And we can tell, because of the positive coefficient in front of x squared, it's going to look like a big U. We're going to get something like this. So boys, there you go. That's a graph quadratic right there. And because this is just pretty much revision for most of you, I'll go through one more example and then we'll close the video, because this is just kind of like a prelude to the next video. Anyway, next example. Okay, so my boys, our second and final example is just going to be an example of the other case where you've got a negative coefficient in front of your x squared and your quadratic. So because this has a negative coefficient in front of x squared, you're going to get this n-shaped quadratic. It's going to come down from here, race up, and then turn back around, right down the y-axis again. Now we know the shape of the quadratic. All we need to find out is where it intersects the x and y axes. So in other words, rephrasing that question, all we need to do is find the roots of the quadratic and the y-intercept. So basically f of 0 we need to find as well. Right, so we need to solve for the roots of that quadratic, and that looks pretty horrible. So let's use the quadratic formula. So we say x equals negative b, that's negative 4, so that's 4, plus or minus the square root of, okay, 4 squared, well, negative 4 squared is just 4 squared, which is 16, minus 4 times, a is minus 4, c is 3, okie dokie, and that's all over 2 times negative 4, which is negative 8. Okay, let's do some simplification. So, negative times negative, positive. 4 times 4, that is 16. Times 3 is 48, if I'm not mistaken. 16 plus 48 is, in fact, 64. And the square root of 64 is 8. So all we get is equals 4 plus or minus 8 over negative 8. Okay, right, let's do some maths. Right, so the first solution is going to be 4 plus 8 divided by negative 8. 4 plus 8 is 12, if I'm not mistaken, divided by a negative 8, which is negative 6 over 4, which is negative 3 over 2. Okay, and the second solution is going to be 4 minus 8 over negative 8, which, again, if I'm not mistaken, is negative 4 over negative 8, which is positive a half. And that's our second solution. So these are our two roots. So these is where it's going to cross the axes. So I'm going to label that here at 1/2 and here at negative 3/2. Okay, my boys, that is smashing. Right-yo. Sorry, I'm just checking if I got that maths right. Yeah, okay, right, anyway, sorry about that, right. So now, to find the y-intercept, all we need to do is plug in x equals 0 to get the input as 0 and such the y-coordinate. And so if we do that, these two terms get killed and we just get 3. Okay, and now we can graph it, taking the n shape because it's a negative coefficient, and we get something like that. Oh god, that's terrible. That doesn't even cross the point I plotted. What a dingus. Anyway, so yeah, there we go. There's a plot of a negative quadratic. Now, that's pretty much it. I'm not going to go over any more examples because that was probably GCSE revision for most of you guys, but I hope that was helpful anyway. I hope that cleared up anything you had. Maybe you could understand why quadratics have the shape they do now. But anyway, I hope that video was helpful to any of you guys. Thank you very much for watching, and I'll see you in the next one.